In the previous module, we had seen that these two parts of the home and attraction screens had the same structure, so we could choose to model them inside a stencil object precisely to reuse them, and then insert it as a control in each of these panels. In this class, we're going to analyze which control hierarchy should be used to implement the structure of the stencil, and in the following classes, we'll see how to make that structure look as defined by our designer in the Figma file. So let's start by creating the stencil in GeneXus. To do this, from this folder, which is where we want to create the stencil object, we choose the stencil object type and name it Information. The layout is initialized with a table called Main Table. As long as we don't place any controls inside, it'll remain empty. If we right-click, it offers us to convert this table into two types of containers that have specific uses. Canvas, which we'll use later to implement the header of the master panel, and that will allow us to superimpose controls. And then Flex, that will allow us to place the elements of the table in one direction, either horizontally, as a row, or vertically, as a column. Let's analyze this layout, which is the one we want to implement in Figma. First, note that here we're positioned in the home frame, which is the one that designs the home page. It has a width of 1440 pixels and a height of 2514 pixels. And they'll all be more or less the same. What does this mean? That if we run our GeneXus objects, our panels, in a browser with these dimensions, the screens should look exactly like this. But, as Chechu told us, this design was devised so that the width can be extended or reduced a bit, and the design adapts to the new width. As she said, this design corresponds to a certain width and small variations of that width. Because if we shrink it enough, we'll have to reassemble these screens, design them again to arrange the information in a different way according to that screen width. This is what's known as breakpoints, where the design must be modified. It'll also be used for tablet, phone, and small variations of those sizes.
Aquí recordemos, estamos implementando la aplicación para tamaño desktop y sus variaciones.
Now let's analyze the layout we're interested in, the one we're trying to implement with the stencil object. It corresponds to this container here, the one named Information, which contains two elements. Another container, the one named Information Title, that we see on the left side of the screen, and a text to the right. The container on the left, in turn, contains another text, this time on top, and a button below, which, as we can see, is an instance of a component. This component will have two layers, one for the background and one for the text of the button, and we'll analyze it later. So structurally, we could organize this screen like this: a table, our main table, with a single row and two columns, where in the first one we have another table, and in the second one, the text control, which in GeneXus could be either a text block or a text variable of type edit read-only. And the internal table would have a single column and two rows, where in the first one, we would place the other text control, text block, or variable, we'll have to choose, and in the second one, the button. If we do it in GeneXus, we already have the table, it's the main table, so let's insert the first element, which is the other table. Let's rename it to match the name that our designer gave it. It'll be easier to find it. Okay, now let's insert the element on the right, which was the text. We can choose to implement it with a variable type control or with a text block. I'm going to go with variable. I'm going to drag it and create it with the same name that our designer gave it, information text. I'm going to set as data type any of those that represent characters. It could be character, varchar, or long varchar. That's the one I'm going to choose. As we'll see, and I'll explain in a little while, choosing this data type will cause the auto grow property to be automatically set to true. One of the drawbacks of variables is that they're write enabled by default. So I'm going to change the read-only property so that it is read-only. The other drawback is that they have a label by default. So I'm going to set the position of the label to none so that it's nowhere, hidden. So as I was saying, I could have chosen, instead of the variable, to represent this with a text block. I chose the variable because it's possible that this information, the content, comes from the back office. That is to say, it's extracted from the database. And it's easier to assign the content to a variable simply with a direct assignment by means of the equal sign than to do it for the text block, for which I'll have to use the caption property. Text block, period, caption, equal, and then assign a value. This is precisely one of the border cases. This text is not going to vary. Therefore, it could very well be a text block. It's clearly its use. We're inclined to use a variable when the content changes. Now, before adding the controls for this table, let's look at the properties of the main table, and in particular, these four. The first one specifies the width of each of the two columns. And the second one specifies the height of the only row that the table has at the moment. What do these values of 50% mean for each column? That its width will be 50% of the total width of the table. And what's the total width of the table? The one given by the width property, which in this case is also a percentage, indicating that the width of the table will correspond to 100% of the width of its container. And what does the PD value mean in the property that determines the height of the rows? Here, it indicates it clearly. It's an abbreviation of platform default. This default depends on each platform, but it's a fixed value. We could specify a percentage, in which case it's relative to the height of the table. Here we also see that it's 100%, or we could specify a value in dips, which is the same as pixels. The dip is an abstraction of the pixel unit that was first used in GeneXus when we started implementing native applications. The equivalence is 1-to-1. Let's place here the 712 dips, or pixels, that we obtained by inspecting the frame in Figma. Does it seem odd that the height of the row is this size, but the height of the table, which only has that row, is 100%? Here's a word of caution. Although the editor is not distinguishing the table border from the row border, they're not the same thing. The table border will extend to 100%, and the row border will correspond to these 712 dips. Controls, by default, take up the entire space of the cell in which they're placed. Thus, if we look at the properties of this table, which is empty for now, its width and height are set to 100%. In other words, they'll take up the entire cell in which they're placed. The same will happen with the variable, and we need to know this because there's no property that evidences it. What will happen if the content of the variable is so large that it doesn't fit in the 712 pixel height of the cell? Since the auto grow property is set to true, as is the same property at the table level, then what will happen is that the cell will expand downwards so as not to leave content outside. If the property were set to false, then the content would be truncated at 712 pixels or dips. If we leave it like this, although the row will be 712 pixels or dips high, as the height of the table was set to 100%, if the container of the stencil has a height greater than 712 pixels, then there could be an empty space. The other option would be to set the row height to 100%, in other words, to take up 100% of the table height, and then define in the table height those 712 dips or pixels. Now let's insert the text as text block in this table. We know that it's a short text, which probably will not change. Let's call it the same as Chechu did in Figma. And to the caption, for now I'm going to leave title, because later on it'll be updated in the Home and Attractions panels with the value that it will have to take in each one. And in another row, we insert the button. If we look at the table properties, we can see that the column is now a single column, 100% of the width, and each row will take the default platform height. Clearly, we'll have to change this. So let's go to Figma to see what values we need for the widths and heights. But before analyzing these sizes, let's analyze the case of the external container. What I want to focus on now is the spacing between the elements and the border of the container. We'll continue in the next video.